Hey, it's Aaliyah from Aaliyah's Electronics, and I want to talk about the different oscillator options, or some of the different oscillator options that PIC microcontrollers offer. Now, the first and easiest to use clock source is the internal oscillator, also abbreviated INT-OSC. Now, it can be configured by software from anywhere from 31 kilohertz to 60 megahertz in different steps. So it's 31 kilohertz, 512 kilohertz, 1 megahertz, 2 megahertz, and so on. And it's cheap and easy to use, as I already mentioned, but the problem with that is the frequency stability is very low, and the accuracy is only from about 1 to 5%. So the accuracy on 1 megahertz is only 1 to 5%, and the drift with temperature is going to be very high. So as the temperature of the chip changes, the frequency will significantly drift with that. Now, another option is that offers more flexibility, frequency flexibility, is the external RC oscillator. And you can see it's just a resistor and a capacitor, an RC network here, connected to the OSC1 pin of the microcontroller. Now, as you can see, it's only a resistor and capacitor setting the frequency of oscillation. It's basically a time constant setting the frequency of oscillation. And this is how you calculate the frequency. And where the resistor is between 1K and 100K, and the capacitor is bigger than 20 puff or 20 picofarads. And the frequency of this RC network can be set from about 30 kilohertz to 4 megahertz. So again, it's low stability because the resistor and the capacitor, the values are going to change over the temperature range, but it allows for a more flexible clock frequency selection, so you can clock it down to 30 kilohertz, which is very low and might be saving a lot of power in a low power mode. Then there is the external clock option, where you feed a square wave from an external source into the oscillator pin. That can be anywhere from 0 to 64 megahertz on the PIC18F14K22, and it depends on the microcontroller from what the maximum clock frequency is, but the stability of this clock is going to be as good as whatever the external source is, and the frequency accuracy is going to be the same. So if you're driving it from a good function generator, then the frequency stability and the drift over temperature should be very good. Now, the most used oscillator option when you need high stability and high accuracy is you will use an external oscillator. So you will use these little external quartz oscillators, like the ones here, and they will allow you to have very accurate clock rates for things like a UART. There are certain crystal frequencies that can be evenly divided by a binary value, or by a power of 2. And therefore they are particularly good to create UART clock rates. So the error in the serial clock rate will be 0, ideally, if the crystal really is oscillating at the given frequency, which it isn't, because the accuracy is about 10 to 100 parts per million, and it's compared to the other to the internal oscillator and the external RC oscillator, it's very high stability, but even the crystal oscillator is going to drift over time and over temperature. And there are three power modes in which an oscillator can be used. There's the low power mode, that's for oscillators up to 200 kilohertz. Then there's the intermediate power oscillators from 100 kilohertz to about 4 megahertz. And then there are the high-speed oscillators from 4 megahertz to whatever the maximum frequency is. That could be, for example, 16 megahertz. And for a crystal oscillator, besides just connecting the crystal to the oscillator pins, you also need to add load capacitors. And these load capacitors are needed in order for the crystal to start oscillating. And you can calculate the value for C by this formula. So you have 2 times the required load capacitance. For example, 12.5 picofarads is very common, minus Ci, which is the input capacitance of the pins, of the oscillator pins, plus the parasitic capacitance of the traces on the PCB. Often you won't care about this term too much, and you'll just use whatever value is coming out of this equation here. For example, on this board, it uses a 60 megahertz oscillator and 22 picofarad load capacitors. That's just one of the standard values that you're going to use, that you'll often find in schematics where you don't really worry about that term because you're not that concerned about drift or stability or actual frequency accuracy. But if you're really concerned about that the frequency is accurate, then you would really take these two capacitances into account. And you might probably want to use a crystal oscillator or even an oven-controlled oscillator that is much higher stability than just a simple quartz. The oscillator mode of the PIC microcontroller is selected in the configuration bits. So you will set the configuration bits at the start of your source code, and then the assembler compiler is going to take care of setting the right configuration bits. You can look these up either in the data sheet, or you can use the MPLAB IDE to calculate these bits for you or set the bits for you. If you like this video, give it a thumbs up and subscribe.